So, graphing secant and cosecant. First of all, why don't we quick review our sine graph? Okay? How would you graph sine? Who wants to take that one? Caleb, what do you got?
Start at the origin.
Start at the origin. Okay, so in blue here, I'll do my sine x, and he said start at the origin. All right.
Go up to 1.
Go up to 1.
And then over to whatever a quarter of your amplitude would be.
Okay, so how far? I mean, what coordinate should I plot? I guess maybe you can just tell me what coordinate that would be.
1/2 pi, right? No,
Yes,
pi.
yeah, 1/2 pi. Pi over 2, right? Okay. So pi over 2. At pi over 2, I'd be up to 1. Okay, keep going.
And then back down to 0 at pi.
At pi, you're back down to 0. Nice.
And then -1, 2 pi over 3.
Careful.
3 pi over
3 pi over 2, right?
Yeah.
1.5 pi, not 2/3 pi. That's all right.
4. And then back to the 0, 2 pi.
Back to the 0 at 2 pi. Okay. I'll continue the pattern back here. This would be negative pi over 2. I'm down at -1. Here at negative pi, I'm back to 0. I'm going to run out of room. Negative 3 pi over 2. I'm up here again at 1. Okay? So, and then in blue here, and you guys might want to just lightly draw the graph on yours. But there is the sine graph, okay? Like I said, I'm going to do it in different colors up here. If you guys want to do it, just lightly draw your sine, because I'm going to show you what the cosecant looks like is what I'm going to do. Okay? What do we know, or hopefully know, is the relationship between the sine function and the cosecant function. Careful on the word opposite. Reciprocal. Yep. Because when we say opposite, we think negative. Okay, or a lot of people would think negative. I knew what you meant. Just make sure you're thinking reciprocal. Okay. So when you go to graph the cosecant function, keep in mind you're really just going to be graphing the reciprocal of whatever the sine value is. Okay. Now that you have a fraction involved, or a reciprocal, when you have fractions involved, there's always a value you can never have in the denominator. What's that value? 0, right? You could never have a 0 in the denominator. You can't divide by 0. Well, is the sine of x ever equal to 0? Was your sine function equal to 0? Yeah, a whole bunch of times. Here, 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 here. All of those places where your sine function is equal to 0, what's the cosecant of that value? What would you write down on your time test? Undefined, right? Not possible. Okay. The cosecant of 0 would be 1 divided by the sine of 0. Well, the sine of 0 is 0, and 1 divided by 0 is undefined. Okay? Because cosecant is undefined here, 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 and here, everywhere where sine is 0. In order to graph cosecant, you're going to draw asymptotes there because it is undefined. Okay? There is not a value that exists. The function is not defined at those x values. So I'm going to draw an asymptote here because the graph will never hit anywhere on that vertical line. I'm going to draw a vertical asymptote here because the graph will never hit that line. Okay? Never hit anywhere on that line. It is not defined for that x value. Okay? Obviously, I could keep going. Depends how large you made your graph, right? Because the graph just repeats itself over and over again.
Couldn't you just draw one horizontal asymptote?
What do you mean a horizontal asymptote?
Just right at. Couldn't you draw one right at there? That'd be where your crosses the zeros.
Draw a horizontal?
Yeah, couldn't you?
No, because the graph, like at negative pi over 2, That's not, I mean, that's not going to be 0. We're going to have a different value, okay? Keep in mind now, we're trying to graph this function right here. And if I plug in pi, the cosecant of pi is undefined. So therefore, those aren't coordinates you can't plot the coordinate undefined. Does that make sense?
Yeah.
Okay? So what I do when I go to graph these, I first of all try to draw all of my vertical asymptotes, or in other words, wherever the sine graph equals 0. Because I know the reciprocal of 0 is undefined, not possible. I can't do it. Okay? Now, let me teach you again how to go with the rest of it. Okay? Let's work with pi over 2. Okay? What's the sine of pi over 2? 1, right? The sine of pi over 2 is 1. So what's the cosecant of pi over 2? Careful. What's the reciprocal of 1? Still 1, right? Okay, we get in the habit sometimes of saying negative. The reciprocal would still be 1. So my cosecant graph actually hits that coordinate as well, right there. Okay? How about at 3 pi over 2? The sine of 3 pi over 2 is negative 1. So what's the cosecant of 3 pi over 2? Still negative 1, right? Okay. So it hits there, it hits there, hits here again, right? Hits here. It's off a bit. Okay. So I plotted a couple coordinates. Some of them are repeats. The reason they're repeats is because the reciprocal of 1 is itself. The reciprocal of negative 1 is still itself. Okay. All right, well, I still don't have a lot to go on. So now I got to get you to think a little bit about numbers and how they work. Okay? Let me take, I'll even just take this value right here. Okay? I don't know what x value that is. Well, actually, yeah, I do. Pi over 6. That's a 30-degree angle, right? What's the sine of a 30-degree angle? 1/2, right? So the sine of a 30-degree angle would be 1/2. What is 1 divided by 1/2? 2, right? 2. So when the sine value equals 1/2, we know the cosecant value would be up here at 2, right? Or wait a minute, 2. Gotta remember I'm counting by. That's 1, that's 2. What about right down here when the sine value is a really tiny decimal? What's 1 divided by a really tiny decimal? Try it. You got a calculator. Type in 1 divided by some tiny decimal. Then try a tinier decimal. Then try a tinier decimal. Okay.
Big number?
Big numbers, right? If you take 1 and you divide it by a super small number, you're going to get a huge answer. Okay? The values are going to keep increasing. So as I move further and further this way, where my sine value is decreasing, what's my cosecant value doing? Increasing. So I know my cosecant value is really approaching infinity as I get closer and closer and closer to 0. Now how about as I start going this way again? What's going to happen? It's going to, well, aren't these values smaller than 1 now again?
Yeah.
And 1 divided by a number that's smaller than 1 is just going to make it increase again? So actually it kind of makes what looks like a little bit of a parabola in between the two asymptotes. Because 1 divided by any of these small numbers that are smaller than 1 will give you a number that's larger than 1. Anytime you divide by a number between 0 and 1, you get a bigger answer. And when you divide by 1/2, you're multiplying by 2, actually, right? When you divide by 1/3, you're multiplying by 3. When you divide by 1/4, you're multiplying by 4. Your numbers are getting big. Okay? So the graph increases, gets very, very large. Okay? If you don't believe me, if you are in degree mode, is anybody in degree mode? Tyler? Type in 1 divided by the sine of 89.999. Okay, so that'd be like right here, right? 89.999. What'd you get?
1. 89.999.
1 divided by.
That's what I got.
Divided by sine.
Oh, wait a minute. That makes sense. How about 90's right here, dummy? How about 179.999? My bad. Almost pi, almost 180 degrees. Not really proving my point very well, am I?
57,000.
57,000 something? Okay, yeah, way up here. Alright. As you get closer and closer and closer to pi, my fault here, I for some reason thought that was pi over 2, 90 degrees. As you get closer and closer and closer to pi, or 180 degrees, 1 divided by that tiny number gives you a huge number, so it makes sense that the graph would be way up there. Okay? Take a wild guess what's going on between these two asymptotes. Just the same, but upside down. Yep. If you take 1 and you divide it by a tiny little negative decimal, you get a large negative number. So all that happens between those, and then it just repeats itself. And since all the further I went was right here, I'm just going to stop right there. Okay. Obviously, it would keep going if I had enough room. Okay. So there is your graph of your cosecant function. Whenever I graph a cosecant function, I think I would say this every single time, even if they made it really complicated. I would probably change it to sine and graph that first. I would almost always change it to sine and lightly graph that one first. Because once I have the sine one graphed, the cosecant is really simple. Okay? Questions on that? Trick question. What if I ask you for the amplitude of the cosecant function? Nope. Those are all good guesses. I understand why you're getting them. Okay? What do we think of when we think of amplitude?
Absolute
Height of the wave?
So would it be
Absolute
like
value.
negative
We don't have waves.
0?
There isn't one. Not 0. There isn't one. There is not an amplitude. Okay? That's why I'm playing trick question. Okay? Because it's not a wave, we can't describe the height of the wave. Okay? This is not a continuous function that creates some sort of wave. It's a periodic pattern, okay? It repeats itself over and over again, but it's not a wave. Maybe jot that down, write it real big in your notebook. No amplitude. Okay? There is no amplitude. If you see that question asked, which I think we do at some point, okay, on the quiz, what is the amplitude of that function? You'd say there isn't one. Alright? So no amplitude. How would I, let's see. So how would you graph the secant function then? Graph the cosine function first. Draw the asymptotes. Then draw the parabolas, right side up and upside down. Okay? If you want to draw that one specifically, you certainly can. Okay? I'm going to do one that requires just a little bit more thought for you. Okay? Let's do y equals the secant of x over 2. was asked to graph this one, I really think I would graph this first. So if you had to graph this one, the cosine of x over 2, you guys that make your tables would go 0, pi over 2, pi, 3 pi over 2, 2 pi, and then what is it for cosine? 1.
0, -1, 0.
Okay. Do we need to change the amplitude or the y value at all?
No.
No. What do we need to do to the x values? Take them times 2, because your period, okay, this is like one, your b value is 1/2, right? So 2 pi divided by 1/2, it's like multiplying by 2. So all these are going to multiply by 2. That's after the new period. If I wanted to go do some more, I certainly could here. Starts up here at 1, down to 0, down to -1, back to 0, up to 1, 0, -1, okay? I think it's easiest to draw your cosine graph first and then draw the secant one from that. Because if you draw your cosine graph first, you know right where the asymptotes are going to be. Where are the vertical asymptotes going to fall? Pi, 3 pi, -pi. Wherever the cosine graph does what? It's 0, right? Crosses the x-axis. Yeah, because if the value of this one is 0, the value of this one is 1 divided by 0, which is undefined. So I know here, here, and here. Vertical asymptotes. And then just draw your parabolas in, and that's good. You don't need to be specific with any coordinates. Just make sure it hits the... Okay? The period, is it the same as the cosine? Does it take 4 pi to complete one full cycle before it starts repeating itself? Yep. Yep. I don't know if you look at it right here. Here's where I'm way up top, right? At -pi. When do I get back there again and repeating it? Just past 3 pi, right? So it took from -pi to 3 pi to complete one cycle, and then before it repeats itself, so it's still 4 pi. That doesn't change. Okay. All right, any questions on that? So if you have to graph cosecant or secant, graph the sine or cosine first, draw your asymptotes, then draw the cosecant or secant function from there. If you would please, for my own benefit, draw in your sine or cosine either dotted or very lightly, so I know that you know that's not actually part of the graph, okay? But just draw it in very lightly or erase it out of there, whatever it might be, draw it dashed. I'll understand what you're doing if you draw it dashed. You know you graph that because it helps you. If you want to enter this on your calculator, you certainly can. There's not a secant button, but you would just have to write y equals 1 divided by parentheses cosine parentheses x over 2 parentheses parentheses. That's cosine of x over 2. And make sure that whole thing's in the denominator. If you type that into your calculator, it'll graph it for you. And you'll have to adjust your window, make sure you're in radian mode, all the above. Okay? So, assignment, just 3 problems. You get the idea after 3 problems. Page 401, 30, 31, 33. Page 401, 30, 31, 33.